Good morning everyone. Welcome to Tutor Master. This is Mathematics, Theorem 1 of grade 11. We're going to start with this theorem. The theorem says a perpendicular line drawn from the center of a circle to a chord bisects the chord. Let me repeat it again. A perpendicular line drawn from the center of the circle to a chord bisects the chord. So in other words, we need to have a chord here. A chord is just a line drawn from the circumference of the circle to the other. So this is a chord, but if it passes from the center, it's no longer a chord, it's called a diameter. So now we're talking about a chord. So let us name our chord. We can say, for instance, A and B this side. So our chord is AB. But we need to follow the rules of the statement. The statement says a perpendicular line drawn from a center of a circle to a chord bisects the chord. So, for instance, I can say, let's name this angle M. So let's try to analyze the statement. If it says it bisects the chord, what does it mean? It means that this part is equal to that part. In other words, it cuts the line into two. For example, right, as I've said, a chord is a line drawn from a circumference to the other. So, if you've got a circle like this, this part of the circle is called circumference. So, part of the circle is called the circumference, and then again, that circle has got a center. This is a center. Right? So if you draw a line from here to here, it's called a chord. But if your line passes the center, let's say it's from the circumference right through the center to the part of circumference here, is called a diameter. So let's not get confused of that. I hope it's clear. Right, back to our theorem. So we're going to prove that, for instance, okay, let me write the statement itself. It says the perpendicular line drawn from the center of the circle to the chord bisects the chord. This is our statement. Now, what is the meaning of bisect? It means that this line cuts this one into two equal parts. Remember, it says perpendicular. This is that it is perpendicular. Right? I will explain the meaning of that. But now, if it says it bisects, it means this part from here to here is equal to this part from here to here. That's what it means. It breaks its line into two equal parts. Now, the meaning of perpendicular, it means it's a right angle here. Meaning that this angle is 90 degrees. Okay? Alright. So now if you are proving such kind of a theorem, what must you do? You should start with a given statement. Let's name again our center O. Okay? So we start with a given statement. You need to explain what have you given here. We are given what? A center. We are given a circle with center O. Right? Circle with center O. With OM. Here is our OM. Perpendicular to AB. I have explained the meaning of perpendicular, that it's a line that makes a 90 degrees angle there. Now, what else? We should go to construction, because we need to construct in our drawing there. What must we construct? We are going to draw a line from the center. Like that, to the circumference. And we are going to also construct another line from the center to the circumference. From the center to the circumference of our circle. So we need to indicate that we constructed or we join OA, here's our OA and OB. That is our OB. Okay? I hope it's clear to everyone. Now, we are required to prove. We are required to prove. Since we are told that this line cuts this guy into two equal parts, it means we are going to prove that AM is our AM should be equals to MB. MB. That's what we're going to prove. That's what we're going to prove. Then, now, where are we going to start, or where are we going to prove here? We should indicate as well that we are going to prove in. First of all, you can see that this is a big triangle. Can you see? It starts here, goes that part, and comes back here. It's a big triangle, can you see? But that big triangle is divided into two triangles. That is where we are going to prove. We are going to compare the two triangles. So, right, we are going to say we are going to prove in triangle AOM or OAM is fine. OMA and triangle OMB. We're going to compare the two triangles. Right. If you can check this line from here to here, it's a line drawn from the center to the circumference. Can you see? That line is called a radius. It's called a radius. And again, another line here on this triangle from the center to the circumference is called a radius. It means that these two radius are equal. Can you see that? It means OA is equal to OB. Now we need to give a what? A reason. So if you are proving theorems, make sure that every time you write statement and reason. So here we are going to prove we need to write 3 statements and 3 reasons. Then we can conclude that these sides are equal. So the reason here is called what? Radii. Myself I call them radii. Others call them radii. Meaning that it's a plural for radius. One radius, but many radii or radii. It's up to you. So they are equal because once they start from the center of the circle, if you can draw another one here to here, will be also equal to another one from here to there. Another one. You can produce many of them. And the fact is that they are all equal. Right, what's another statement? Right, if you can check, these two triangles are separated by one side. Can you see? They are two triangles but separated by one side. It's like you at home, you belong here. Your neighbor belongs here. And then you share what? One wall. So, in other words, this side is equal to that. If you can cut this here, you will see that this is equal. So, in other words, OM is equals to OM. Now, what is the reason? The reason is called common side. Right? It's a common side. I hope everyone can see that. Then we need the last statement here. Our last statement is that you can see this angle here. It's 90 degrees, right? It's 90 degrees. But this line, it's a straight line. Do you agree? This is a straight line. And that straight line has been cut into two equal parts, then it means this angle is equal to that angle, because both of them are what? 90 degrees. So we're going to say, okay, angle AMO is equal to angle BMO. What is the reason? We are given, this one is a given statement. From the statement above, we are told that it's a perpendicular line, so we just have to write given. So if it's like this, your job is done. You found your statements and reasons. Then you can say now that this triangle OMA is congruent to triangle OMB. What is the meaning of congruency? It means the two triangles have got what? Equal sides and angles. So this side equals to that side, this side equals to that side. Then what does that mean? Because we were comparing these two triangles. So it means this side as well equals to that side, which is what? AM is equals to B. And this is what we were proving. So if you come up here, it means we have already concluded your job. Again here, if you write the congruency, you should give reasons. You should give reasons. Be careful here when you're giving reasons under congruence. You need to check what you have proven. OA and OB. If you check OA and OB, these are sides, right? These are sides, so it means we are going to write as OM and OM are sides as well. You can write as, but here you can see that these are angles, because we've got this to show that these are angles. Then you can see, but you know that it's a 90 degrees, that angle. You can write 90 degrees. Or you can also do like this. Right angle, hypotenuse, side. Yeah, you can also write it in that fashion. Yeah, this is the first theorem for grade 11. So I didn't want to go far because I don't want to confuse people here. But we will take it slowly until we get at the end. So I hope everyone will go and familiarize themselves with this important theorem. We will come next time talk about converse and other theorems.